In a right angle triangle, you can see this right angle triangle, children. The square of the hypotenuse, the square of the longest side, that is the hypotenuse, is equal to the sum of the squares of the remaining two sides. The square of the longest side is equal to the sum of the squares of the remaining two sides. So what do we have to show, children? That AC square, the square of the longest side, which is the hypotenuse, is equal to the sum of the squares of the remaining two sides, which is AB square plus BC square. So in order to show this, we have to undergo, okay, now in order to show that AC square is equals to AB square plus BC square, children, we need to undertake some construction work and see what are we going to construct. We are going to drop a perpendicular on the hypotenuse from the opposite vertex, that is B, and let that perpendicular meets the hypotenuse at D. So the construction that we have undertaken is drop BD perpendicular to AC. Now the actual proof starts. Let us take the small triangle ABD and ABC. So consider triangle ABD and the containing triangle ABC. Let us see what they have in common between them. ABD and ABC have angle A in common, right? So angle A of ABD is equals to angle A of ABC is a common angle between the two triangles. Common angle, common vertex. Now we are talking about ABD first. So angle ADB, isn't it 90 degree, children? Angle ADB. So angle ADB is equals to angle B, which is also of 90 degrees, right angled at B. We have learned angle ABC, triangle ABC is right angled at B. So of triangle ABC, it will be equal to angle B. Both are equal to 90 degrees. So by double A similarity, as we have learned that this is one of the criteria, by double A similarity, I can write triangle ABD similar to, now the order is very important. Triangle ABD is similar to triangle A. Why? Because A corresponds to A talks to A in such a way you can understand. In place of D is the third letter, you should write B, right? So you should write B and the remaining one will take the empty place. Now, as we know that when the two triangles are similar, the ratio of the corresponding sides of the two triangles are equal, right? So let us take AB, the first two letters, then I have to place AC in the denominator, AB over AC, right? Now let us take AD. So I will have to take AB from there. When I cross multiply, children, I get AB square is equals to AC into AD. So you need to mark this important observation number 1. Similarly, I have to take two triangles BCD and ABC. Again, in triangles BCD and triangle ABC, we need to compare the smaller triangle BCD with the bigger triangle ABC, like we did with ABD and ABC. Can they be shown similar? Let us see. You can understand, children, like angle A was common between the previous two triangles, Angle C is also common between these two triangles, right? BCD contains C and ABC also contains C. So angle C of this triangle is equal to angle C of that triangle, common vertex or common angle. Common vertex. So the measures will be equal, right? Now you can see angle CDB. Angle CDB of BCD is equals to angle B. Why? As usual, 90 degrees. CDB, by construction you dropped BD perpendicular to AC. Again, by double A similarity, triangle BCD is similar to, now the sequence of letters is very important. See, B is talking to B, you can see that D is talking to B. So in the place of third letter, you should write B. Now what shall come in the place of the middle position? C is equals to C and the remaining letter will take its place. So triangle BCD is similar to triangle ACB. Now we know that when the two triangles are similar, children, the ratio of the corresponding sides are equal. So I can say that the ratio of the corresponding sides are equal. The ratio of corresponding sides are equal. Thus I will write BC over AC, the first two letters, and here the first two letters, BC over AC.